So let's look at some examples involving the second fundamental theorem of calculus. So let's say I want you to evaluate the derivative of the integral from 0 to x square root of t squared plus 1 dt. So the first thing we're going to do is look at our function f of t inside of the integral. It's t squared plus 1. And because it's t squared plus 1, what's inside the square root will always be positive. And so in particular, this is continuous on the interval negative infinity to infinity. So in order to use the second fundamental theorem of calculus, your function has to be continuous, which it is. And so by the second, and I'm going to abbreviate fundamental theorem of calculus as FTC, the derivative from 0 to x square root of t squared plus 1, you just replace t by x squared plus 1. There's my derivative right there. Okay, so what happens when your upper bound here, the number in the top, what if that's not just x? So let's look at an example there. Say I want you to find the derivative of the function f of x, which will be the integral from pi over 2 to x cubed cosine t dt. So the problem is that x cubed, it's too complicated. We wanted it to just be an x. So the idea here is that we are going to use the substitution u equals x cubed. So I'll say by the chain rule, we have that f prime of x, it's the derivative of f with respect to u times the derivative of u with respect to x. And so for this first term right here, we're going to get, it's the derivative with respect to u from pi over 2 to u cosine t dt. And remember, u was x cubed, so what's du dx going to be? It's going to be 3x squared. And now, here I'm taking the derivative with respect to u, and this is just a u up here, so you can use the second fundamental theorem of calculus to say that this is cosine of u times 3x squared. And for your final step, we need to have plug back in what was u? It was x cubed. So here is my here's my derivative. So basically, remember what we had before was the integral from pi over 2 to x cubed. It was cosine t dt. So basically, you plug in this x cubed in place of t, but you have to multiply by the derivative of x cubed. You can also verify that this is the correct answer explicitly if you want. So verify your answer by finding capital F of x explicitly. So capital F of x, remember it's the integral from pi over 2 to x cubed cosine of t. So f of x, the antiderivative of cosine is sine, So this is sine of x cubed minus sine of pi over 2. So my capital F function, it's sine of x cubed minus 1. And then to find the derivative, f prime of x, you're going to have to use the chain rule, cosine of x cubed times 3x squared. And that's exactly what we got in our answer.